All right, welcome back to the Fourier series coefficient. In previous video, we have seen the integrals of periodic function. Let's see how we can apply those integrals of periodic function in finding the Fourier series coefficient. But first of all, what are these Fourier series coefficients? First of all, know that the Fourier series of a function f of x is equal to a naught over 2 plus the sum as n equal to 1 to infinity of a sub n cos nx plus b sub n sin nx. So this is the Fourier series for any given function, the Fourier series expansion for any function. So now, ask yourself now, what are these Fourier series coefficients? Obviously, if you see, we have a naught, a sub n, and b sub n as like constant. So these constants, a naught, a sub n, and b sub n, are the Fourier series coefficient. So it means that if we have any given function, f of x, and we are asked to expand that function, we know what we can just simply put in the value of that limit x and evaluate, but there are three things we don't know: a naught, a n, and b n. So we want to see what are these coefficients or these constants: a naught, a sub n, and b sub n. We want to find their values or integral. But first of all, see, we are going to do something. We are going to do something. First of all, we are going to integrate this function over a single period. We are going to integrate this function with respect to x over a single period. That is, we are going to integrate the function from minus pi to pi. Don't forget, we said integrating a function over a single period. We are simply integrating from minus pi to pi. So if we integrate this function from minus pi to pi, we are going to find a naught. And then also, Joseph Fourier actually said that, okay, after integrating this function from minus pi to pi, let's multiply this function with cos and then integrate also from minus pi to pi. And then we should also multiply to compensate it. We should also multiply the function with sine and then integrate also from minus pi to pi. And if we should multiply this function with cos, we are going to find a sub n. And if we should multiply this function with sine, we are going to find b sub n. So that are the three things we are going to do to find the Fourier series coefficient. The first one, integrate from minus pi to pi. The second one, multiply by cos and integrate from minus pi to pi. The third one, multiply by sine and integrate from minus pi to pi. So let's start with the first one. The first one, we are asked to multiply. The first one, we are just asked to integrate from minus pi to pi. So if we should integrate from minus pi to pi, we are going to have the integral from minus pi to pi of f of x with respect to x. That is the first one. The first one, we are asked to integrate both sides with respect from minus pi to pi. And also, if you should integrate a naught over 2 from minus pi to pi, you have the integral from minus pi to pi of a naught over 2 dx, a naught over 2 dx, plus the sum as n equal to 1 to infinity of the integral from minus pi to pi of an cos nx dx. Don't forget, we are integrating both cos and sine, plus the integral from minus pi to pi of b sub n sine nx dx. So this is what we have. So you see now, you see the reason why the integral of periodic function are actually important. If you observe here, we don't know the function f of x, so we have to leave this. So we have the integral from minus pi to pi of f of x dx, and this is equal to a naught over 2 is a constant, because from the starting we said that a naught is a constant. So we have a naught over 2, the integral from minus pi to pi dx. plus the sum as n equal to 1 to infinity of an is also a constant. An, the integral from minus pi to pi cos nx dx. B sub n is also a constant plus b sub n, the integral from minus pi to pi sine nx dx. So this is what we have. All right. The left hand side, we have the integral from minus pi to pi of f of x dx. The integral from minus pi to pi of f of x dx. The next one we have is a naught over 2 equal to a naught over 2. If you should integrate the x, you have x. Don't forget, if you integrate the x, you have x into x from minus pi to pi plus the sum as n equal to 1 to infinity of now just relax and check this very well. We have the integral from minus pi to pi cos nx dx, and if you should check the integral of periodic function we treated before this video, we have seen that the integral from minus pi to pi of cos nx dx is 0, and also the integral from minus pi to pi of sine nx dx is also 0. So we have seen now that at the time we did not solve for integral of periodic function, we have to start integrating all these functions, and which is a waste of time. So it means here is 0, here is 0. So 0 times b sub n is 0. 0 times a sub n is 0. 0 plus 0 is 0. 0 times summation is still 0. So we are going to have 0 here. So this implies that the integral from minus pi to pi of f of x dx is equal to a naught over 2 into, if you should substitute your upper limit, you have pi minus, substitute your lower limit, minus pi plus 0. So this means that the integral from minus pi to pi of f of x dx is equal to pi minus pi will give us pi plus pi, which is 2 pi, a naught over 2 into 2 pi. So 2 we cancel out 2, we have a naught pi. But what are we looking for? Don't forget, we are looking for a naught, so we have to divide both sides by pi. So this implies that a naught is equal to 1 over pi, the integral from minus pi to pi of f of x dx. So we have successfully found the first constant, a naught. So let's find the second and third one. Now, Joseph Fourier asks us to multiply this function by sine and cos, and then also integrate from minus pi to pi. So the first one, I would like to multiply this function by cos first, then integrate. So this implies that we are going to have, we have f of x here. If you should multiply this f of x by cos nx, remember, don't forget, the sine and cos we are multiplying them is cos nx and sine nx. So if we multiply f of x with sine nx and cos nx, the first one there is cos nx. So if we should multiply f of x with cos nx, we have f of x cos nx, and then we should integrate from minus pi to pi. We should integrate it over a single period. The integral from minus pi to pi with respect to x. So this is what we have. Also, if we should multiply a naught over 2 with sine, with cos, we have a naught over 2 cos nx, and then integrate from minus pi to pi with respect to x. Then the next one we have is the sum, plus the sum as n equal to 1 to infinity of if we should multiply an cos nx, so you have an cos nx cos nx, an cos nx cos nx plus b sub n sin nx cos nx. So this is what we have. And then integrate from minus pi to pi. So we have to integrate this from minus pi to pi. Don't forget with respect to x. So it means that we are going to have the integral from minus pi to pi of f of x cos nx dx, and this is equal to. Now, observe carefully again. A naught over 2 is a constant. If we should bring a naught over 2 and integrate from minus pi to pi of cos nx, we will get 0. So it means here is 0. 0 plus the sum as n equal to 1 to infinity of. Now, observe again. We have to distribute this integral an cos nx cos nx dx plus bn sin nx cos nx dx. So we are going to have the integral from minus pi to pi of an cos nx will give us cos square nx. So we have cos square nx dx. Then the next one we have here is plus the integral from minus pi to pi of b sub n sin nx cos nx dx. Then we close our brackets. So this is what we have. So let's integrate that completely. All right. But please, take note, you can decide to multiply the function with cos nx. It's still the same thing. You can multiply the function with cos nx. And if you should multiply this function with cos nx, you have cos nx cos nx. And this will give you two answers. If n is equal to m, you are going to have cos nx, which is now cos square nx. And if n is not equal to m, you still get 0. So it's still the same thing. So we are going to have the integral from minus pi to pi of f of x cos nx dx, and this is equal to. Now, an is a constant. Don't forget, an is a constant. If we should bring out an and integrate cos square nx from the integral of periodic function, we have seen that cos square nx dx is equal to pi. So it means here we are going to have an pi, and sin nx cos nx from the integral of periodic function is equal to 0. So the whole of this is 0, and this is an pi. So we are going to have the sum as n equal to 1 to infinity of an pi. This is what we have. Now, this sum as n equal to 1 to infinity does not really affect our a sub n. They are only telling us that a sub n is 1, 2, 3, 4, a1, a2, a3, a4 to infinity. So the sum is not really important. We can decide to remove it. That is if you wish. So we have the integral from minus pi to pi of f of x cos nx dx, and this is equal to, if we remove this, we have an pi. So we are looking for a sub n, so we have to divide both sides by pi. So we have that a sub n is equal to 1 over pi, the integral from minus pi to pi of f of x cos nx dx. So this is what we have. Alright, so we are going to multiply both sides now by sine and integrate to find b sub n. But because of time, I would like to be fast about that very integral. Alright, so we have to multiply this function by sine and integrate. So if you multiply by sine and integrate, you have the integral from minus pi to pi of f of x sine nx dx, and this is equal to a naught over 2, the integral from minus pi to pi sine nx dx, and then plus the sum as n equal to 1 to infinity of the integral from minus pi to pi a sub n sine nx cos nx dx plus the integral from minus pi to pi of b sub n sine nx sine nx dx. So this is what we have. And of course, we are going to have the integral from minus pi to pi of f of x sine nx dx, and this is equal to, if we should integrate sine nx with respect to x over a single period, you have 0. We have seen that in integral of periodic function. So 0 times a naught over 2 is 0, plus if you should integrate sine nx cos nx over a single period, you still have 0, plus the sum as n equal to 1 to infinity of 0 plus sine nx will give us sine square nx, and the integral from minus pi to pi of sine square nx from the integral of periodic function is pi. So we have plus b sub n pi. So this is what we have. So the integral from minus pi to pi of f of x sine nx dx is equal to, this is 0, this is 0. The sum as n equal to 1 to infinity, as n equal to 1 to infinity of b sub n pi. So let's make the sum as n equal to 1 to infinity. We said it does not really matter, it's just telling us that n is equal to 1 to infinity, so we can still remove it. So make b sub n subject of formula. You have b sub n equal to, divide both sides by pi, 1 over pi, the integral from minus pi to pi of f of x sine nx dx. So this is what we have for b sub n, and this is what we have for a sub n. So let's write out the three Fourier series coefficients. The first one we have there was a naught equal to, equal to 1 over pi, the integral from minus pi to pi of f of x dx. And the second one we have is a sub n, and this is equal to 1 over pi, the integral from minus pi to pi of f of x cos nx dx. And the third one is b sub n equal to 1 over pi, the integral from minus pi to pi of f of x sine nx dx. So these are the three Fourier series coefficients. So please, before we start solving question on Fourier series, there's one last part I would like us to take first, and that part is even and odd functions. We want to see when our functions are even and odd, what will be the Fourier series coefficients. Then after that, we can now start solving infinitely many questions for Fourier series. So please check out for the next video for even and odd function for Fourier series. Please, thank you for watching this video. Please, if you are not subscribed or if you are new to this channel, please like, share, and subscribe.